So welcome everyone. Stephen Ashley, I'm the Digital Transformation Solution Centre Manager here at the IIOT. Why this is interesting, we talk to many companies, both operators and supply companies, technical companies. Most people are struggling on how to use data, and everyone's heard about the Internet of Things. How do we use data? How do we use data more effectively? And what is this IoT thing? Is it my fridge talking to my rotating equipment? What is it? How is it really going to help? So it's a really important subject. I think there's a great opportunity. We've invested in a number of projects in this area, and we're looking to do more. And I think Steve's really going to help us with the subject.
So thanks very much for coming. I had nightmares that I was going to be speaking to an empty room, and literally was waking up in the middle of the night, so I really appreciate everyone coming here to make me feel a little bit better. Like I said, I run an intelligent plant. We've been going about 13 years, looking at oil and gas data and doing things with it. I thought I'd like to talk about the opportunity first and the reason why we should be doing this. So I think about the North Sea a lot because I'm from Aberdeen, so pretty much everything in Aberdeen comes through the North Sea in terms of money. And when you look at production in the North Sea and production efficiency, the production efficiency was really low. It's getting better, but there was about 70% production efficiency in the North Sea. What that means is, if it was ASDA, then about a third of the time when you went there, it would be shut. So it's not that ASDA was working efficiently, it actually wasn't working 30% of the time. And that's quite a big deal. And when you take a look at that, if you take that 30% and say, well, we don't know what the improvement could be on top of what we're doing already, but even just what we're not doing, and work out that to 2035, so I think about that as a good retirement thing, then that's about 1.4 billion barrels of oil that would come out of the North Sea extra than if you didn't sort it. So I was trying to think of a number to work out what it's worth. And that's $56.7 billion. And that's at $40 a barrel, which is slightly more than half what the oil price is just now. Now, when you look at the production efficiency in the North Sea, a lot of the problems are actually around rotating equipment. And this was a public study on the right. It's a really big document, and I took a table and I turned it into a pie chart because it had an amazing message embedded in the middle of this massive document. They were analysing compression outages, which is the cause of most of the outages in the North Sea. And they went back and figured out what caused them. Now, if you speak to anyone in oil and gas, what they'll say is, well, we weren't maintaining it right, that's why the compressor tripped. Or it's not designed for the purpose. Not many people talk about how it was operated. And yet that was 55% of the reason that they went down. So in my mind, if you get it right and you analyse things, you can actually point people to how we can operate better and solve that problem. So that's the business problem. When it comes to IoT and oil and gas, that for me is a massive opportunity and a clear direction of what we need to do. So I thought I'd build a story, and I was trying to put it up without words. This is the best I could do. When we create a capability for an oil and gas company, what tends to happen is we have an idea, we build something, we show it to the operator, and then there's some cost. And it's usually quite high. It's quite hard to get something installed in an oil and gas company that's going to look at their data. And so the operator's got quite a hard choice. He's going to have to spend a lot of money up front. He's going to have to do a lot of work up front to try and understand what he can do with this. So he's either going to justify the cost, and he's kind of taking a risk because he's not sure if it's going to do something at this stage, or he's going to start using it. Now, if he starts using it, and this has been developed without his data, what usually happens is it fails. It'll fail in the first few days, and then he gets a bad taste in his mouth and he doesn't want to do it anymore. And that's the honest thing that tends to happen when we're doing these applications. If they're installed locally and there's an upfront cost, it creates a bad reputation for this type of technology. So what usually happens is what's on the right, and they end up just putting their heads against the wall and you can't get anything done. So we're thinking about how we can change this. Because this is a situation of meaning that actually a lot of data is not analysed right now. And it's not that hard. The other way that things tended to happen is where the operator actually led the technology. And to be honest, that worked a lot better because they had the data. So they were able to go and build models and prove they worked and learn from them. But the problem with that is that they end up having to maintain them. And every operator is then maintaining something totally different that's doing the same thing. And that's quite a big overhead, especially when you've built it on top of a platform that's probably changed. You end up rebuilding things again and again and again. So that's another problem. It's a lot better because usually you came out with something that worked, but it wasn't so good because it wasn't across the industry. So I'm asking, is there another way? And this is what I think is the other way. This is the Industrial App Store. You can go online on your phone, go appstore.intelligentplant.com, or search Google for Industrial App Store. It's the first link. This connects to an oil and gas company's data, and there are oil and gas companies connected to this already in multiple regions. And they can then use any app from any vendor to analyze their data. So any vendor can publish a capability, and without having to go through the expensive process of installing it at the site, get that proved, allow the operator to try it, and let them rent it, so that then it's easier to get started, and it's more likely that something's actually going to happen. So in this space, we went through a bit of a journey, because trying to get connected is actually really hard. We had to go through that hard part that we talked about in the first set of slides to get this going. It actually meant a few things. One, we had to build enough apps to get an operator to want to go through these hoops and do this. And two, we had to build a platform to allow other people in. The challenge now is actually, to be honest, making sure that other vendors feel comfortable to put things in here and know that we are trying to help, because we are. We're here to try and help other people put things in here so that the operator can get more gain from really good specialists who do one thing well. So I'll show you a couple of videos. This is, yes. This is a thing called Well Intelligence. It's one of the apps. And here we've gone in from blank. And what we're doing is we're selecting wells in terms of choke positions. And that's the production. The guy that did this is supremely fast, so I might have to pause it. But what we've done there, we've said, here are all the chokes, the production chokes, the gas chokes for the wells. And we've said, this is what the production tag is. So these are pieces of data that the operator already has. And right now, they'll look at them in trends, so just in lines move up and down. But what this is doing differently is it's looking over the history. So pause that there so that we can look at it. But every time you go into this, it builds a new model. It looks at all of the history, and it trains a neural network to predict production from all the things you can actually change, which are the choke positions. So if I play again, you'll see it comes out with a model, and then up here it'll start giving suggestions of things to do. So you see that if we move this, production will drop 2%. And then we've got a list of different things we could do. We'll start to do that. So it comes out with a list of different things we can do, different valve positions that we can move, and the change in percentage on production we can make when we do that. It does it in two different ways. One, if I could move one thing, which one should I move? And two, if I could change everything, what would be the best place? It could be completely different to where we are now. So it does both of those. I'll actually let it play a little bit and then we'll go to the next one. What's special about this is it doesn't actually need a lot of instrumentation. Everybody knows what the choke position is because you set it. And usually we struggle subsea because a lot of instruments fail. So if we were basing it on, say, temperature, usually the temperature is failed on one by all, and it's really hard to model. But in this case, we're actually looking at the production rate itself, which you've usually got a fiscal meter, and then the choke positions, which is something you set, so you know what those are. And here what we're actually doing is saying, I'm willing to move this valve between here and here, and then allowing the model to then go and run between those positions and find what the best place is there. Because some things there are restrictions and reasons you wouldn't go beyond a certain point. And that's providing those suggestions at the bottom. So this is a tool called Well Intelligence. We're currently coming to the end of an OGTC project on this with Marathon. That's, well, hopefully we'll be able to publish something soon on So that's one app, and it makes use of one type of data, which is the stuff you get from chokes and the production in terms of their weight. This uses something else. So this uses alarm and events. You get them from the control system offshore, and what happens offshore is you've got guys that are actually operating the plant, and they'll be moving things and making changes. And every time they move something, it gets logged. And every time that something happens in the plant, that also gets logged. So you can tie these things together, and that's what this app does. So here, every circle is something that's happened. This is actually 6 months of data for one compressor. I'm going to try and get the pause rate this time. So 6 months of data for one compressor. And it's all the events around compressor switching off. And it's trying to tie them together. If you've ever seen a bow tie diagram of cause and effect, so you've got all of the causes of something, you've got the thing that happened, and then all of the effects of that. This is building that from the data. So it knows nothing about oil and gas. It knows nothing about compressors. All it knows is, I've looked for this thing, which is an off-normal alarm on the compressor, which means the compressor is switched off. And I've found all of the things that happened around that. And then I've gone back and said, right, this tends to happen, and then this tends to happen. And looking at all the times together, we can actually start reducing this down. This is where it gets insane. So we've got, when you look at this originally, there's just massive circles, and it's quite hard to understand what to do. Where this gets finished is when we start moving this slider. So here we're going, I only want things that always tend to happen. So this is us saying, there are 21 trips in 6 months. This is real data. So a real compressor in 6 months switched off 21 times. Think about that as well. That's like 6, 7 days, and then it's off. 6, 7 days, and then it's off. That's how big a problem this is in most operators. So we said, if it's in at least 5 of those 21 things, I'm interested in seeing it. Because then it might be something that's common, that's happening, that's causing us a problem. And here, red things are alarms that come up in the control system, and blue things are things that guys did on the control system. So each of these, we call these interventions, these are alarms. The green one's actually a return. And the size of them is how correlated they are. So that means something big almost always tends to lead to that. Something smaller sometimes leads to that. So the cool thing with this is, we can now go, okay, what's the original initiating factor in this compressor trip? It's these actions. Because time comes from the left in. And the fact that these blue things are on the outside isn't because they're blue, it's because they're the first thing that's common in those trips. So now we can say, when you do this, or you do this, or you do this, or you do this, or you do this, you're likely to cause the compressor trip. And that's likely something we have no idea over, because it takes a long time to get from there to there. And there will be blue things in between that weren't related, but we wouldn't know which one caused it. Right? So, with this tool, you can then go back, hover over them, and then we can see UCP shut down better trip. This is shut down on events. We're starting to look at each of the things that happened on the way there. The average story is that here are power problems, here are process problems. These are actually choke valves being moved, and that's the off button for the compressor. So sometimes they actually press off. I don't know if they meant to, but sometimes they did. This is a tool that's called SEER, and it's an example of the sort of thing you can do with this data. In terms of alarm event data, I've not seen anyone do things to try and improve production using alarm event data. Usually people look at it, and what they do is they say, there are too many alarms, how do we get rid of them? And that's what we think about. But there's actually a really rich data set through the App Store. Anyone can get to that. You can publish something and never see the operator's data. They'll never see the capability you published. But the operator will be able to use that on their data through the App Store. So now I'm going to jump. So that was speaking totally oil industry. Now we think consumer and hobbyist. Right? When we talk about sensors from that perspective, it's a totally different world to the oil and gas story. 14 quid to buy all those sensors. I get into this stuff because I quite like it. And the invoice on the right is for 50 of these. So this was 50 temperature sensors wired to my spec and by a factory in China for $177 and delivered 50 of these. That's mental. I can use 50. That's the minimum order I could do. So I took that and actually one of these, real size of that is here. This is what's called an ESP8266. It's a chip. And it talks Wi-Fi. And you can plug sensors in and they'll run code. It's a total computer. So I took to doing my work job at home and I stuck sensors all over my central heating and hooked it up to that thing, sent it all to the App Store and started using apps on the data. What could happen? The honest answer is I upset some plumbers. They really didn't like it. So I'll show some of the charts from where I've moved to now. My previous house, I was putting in underfloor heating in. And I put sensors in the underfloor heating as they put it in. And I couldn't understand why there was this funny kink in the graph. I said, this is weird. And I realized it's the wrong way around. They're putting the hot in where the cold goes. I said to the plumber, this is the wrong way around. And he said, what do you mean it's not that way around? I've done tons of these. And I showed him the graph and he went, oh, you're one of them. But in my new place, I hooked all this up. So here we've got 4 temperatures. So it's really simple. 4 instruments. And there's a temperature coming out of the boiler, there's a temperature going into the hot water, and there's a temperature coming out of the hot water. So imagine the hot water going in and coming out. What's interesting here is my hot water was just staying on. It was just on the whole time. And I had no idea, without going up the boiler and waiting to see when it went off. It's much easier if you've got a temperature. So I looked at that and I was like, this is a bit weird. And then I realized, actually, our temperature in the tank is set higher than 70, and the boiler's set at 70. So the boiler's always going to be on, because the tank's never going to stay small enough. So I turned up the boiler temperature and I turned down the tank temperature. This might be in everybody's house, because this was what I moved into. And now it switches off, far more efficient, right? And you can see the analogies in any industry with this stuff. If you can save gas in your boiler just by turning a couple of knobs, imagine what you can do in oil and gas. I thought about the reason why this happens, because it's probably true in your house too. Condensing boilers, modern, really efficient, only when the inlet temperature is below 55 degrees C. Hot water tanks must be above 60 in order to kill Legionella. So there's actually a tension there, and every time the boiler guy comes, he turns it down. But he's not thinking about the tank, because he's thinking about the boiler efficiency. So it's about thinking about the whole system. And there are other things that have happened. This one I've not fixed. But this is central heating's on. The hot water's on. But the central heating temperature is coming up. And it shouldn't be doing that. And when the hot water switches off, you see this kink. That's because there's a sudden flow as the other valve shuts. And that shows that that valve's passing. Now all I've got is 4 temperature instruments. You figure out all this stuff, and this is the sort of stuff analytics can do for you. So I think there's a best of both worlds around the consumer side and the industry side. There's a lot of stuff the industry does really well. Storage and Queen optimized it in the 1980s. These guys in the IoT space think they're doing it differently. They're not really realizing a lot of the stuff we can do well. So we can do really high compression, really fast query, get fault tolerant stuff, because you don't really need that when it's your heating. It's like, yeah, it works, but it's great fun. So I think a combination of both of these things, cheap sensors, you imagine throwing them onto an oil and gas plant and not having to put them into the control system, not having to do all that extra work. So this is a diagram that shows how all this is connected together. Over here we've got operators connected with their data. Their data stays there. And then over here we've got apps from other people. And they are published wherever they want to publish them. So they can then make use of the operator's data and effectively write new stuff back and show them things that they didn't know. And it's my job to make sure that we find as many of the people that want to develop these as possible and get them connected into the App Store to make sure that these guys want to connect their data. And that's my talk. Thank you very much.
Steve. So let's get you around. Okay, so now we have about 20 minutes for Q&A. So has anyone got a question either around the boiler or rotating it?
Was your plumber called you registered?
Yeah, he was. Yeah, he did.
I started things a plumber, that was also.
Yeah, he was.
Steve, thanks. Great presentation. I've actually got a question for the other Steve, but you can obviously add into it too. You mentioned that IoT was maybe a misunderstood or not understood topic. I find that quite strange because the topic has been around for quite a while now, and AI and machine learning is in everybody's tongue at the minute. So, are the two disconnected, or is somebody not listening, or what's the issue?
So from my perspective, I think people know the term, and so in the industry they've heard GE and everyone talking about industrial Internet of Things. I think it's them who turned that idea. Internet of Things and showing how things are connected and everything will be connected to everything else. But the question is a little bit, so what? And how does that drive value for me in my particular challenge or my asset? And then when we've got too much data anyway. I can't use all the data I've already got, so why do I want more data? So I think it's really a bit about how do we get to a situation where we have the right sensors that are working to solve the particular challenges we have for a particular asset, whatever those are. Okay, so then how do we connect, how do we collect that data, and then how do we start making use of it? And then how do we collaborate around some of those things? So, this is, and Steve with his putting data together with vendors through an app store in this case is one way of doing that. But people struggle with, well, how do I get access to data to practice on, to look at my analytics, my tools. But generally I think the problem is, where do I start with this stuff? And what's the value?
IoT is, it is a word that doesn't have meaning. It's not like you can just go buy it. It's not really well packaged. The picture I had of all the sensors, can you imagine the work that, hobbyists do all the time, because it's great fun. But to do that in the real world, it's actually a bit different. It's not like you can go, I want to buy IoT and go to a vendor and then you get it. It needs to apply to your domain. Yeah.
Okay, so is the issue or opportunity that we need IoT companies that are providing solutions? So in the same way you go to a mechanic if you need your car fixed, actually, the problem is actually nobody's delivering an IoT service.
I would say yes, and especially when you say, so I've got my mind of what it means to me, and it's a little bit different to most of the other people. For me, it's about putting simple things in a box that someone can use. Because it's quite, if you look at like Microsoft Azure and all these other platforms, if you go and try and do something with machine learning and all the rest, you have to do it. It's not something you can just go click and then it gives you an answer. They effectively give you a programming language and say, here you go. This, you can do machine learning. Here you go, and then they leave you to write it. So there's a sweet spot where you take a common problem and then you build something around it. Well, intelligence is an example of that, where it wouldn't help you optimize your boiler, but it would help you optimize wells. So it knows about wells. It's like if it was born, you know how to breathe and stuff. It knows some things, and the rest of it figures out from the data. And getting that balance right, so that you can create something that's not too dependent on an individual site and can be used in multiple places. So I'm thinking about IoT more in the app space, because that's where I tend to think. I think in sensors, it's a bit of a challenge in oil and gas, because sensors tend to have to be safety rated. And so most of the stuff I use, and obviously you just couldn't use in an oil and gas company.
Just picking up on the question behind about how does it work, and I'm actually not really so excited about the idea of solution companies, because I think as a buyer of services in an oil company, I see a lot of people pitching me solutions. And when they're things I don't really understand, it's very tough to make that value proposition stick, particularly when you're trying to select between people who say they've got great solutions.
Yeah.
What I really like about your App Store approach is the opportunity to mobilize all sorts of people you might never otherwise have met on your problem by making your data available.
Yep.
It throws up a bit of a potential challenge, and I wonder how you think about this, which is that oil companies can be quite conservative about their data, particularly where it may be commercially sensitive.
Yep.
And having someone being able to see the value that they can't see in their own assets might at times be problematic. So if that person was going to come on and offer you some money for that asset.
Yep.
So how do you foresee that aspect being dealt with?
I think it's always good to mention DEC in this. This is going to sound a bit random, but all production figures for the North Sea are published. So there is no really secret production figure. Though everyone talks about it, like we need to be really secretive, down to the well level, that's published by government. So, so that's not so much of a concern. But getting connected is the hardest part of the operator side of my job. There's the app provider side of the job in terms of getting them comfortable. Getting the operator comfortable with putting their data in, I completely agree. It's not easy. It took us 2 years to convince the first one to put stuff in. So we had all of that available for 2 years before we managed to get one connected. But the cool thing is, once we did, if anyone else publishes an app, then it will probably not take 2 years for them to start using that. It'll be a lot shorter. It's still a challenge, because they'll still have to say, yeah, we're happy for that app to see our data. They'll still have to consider that. They won't have to install anything locally, so there's a lot of processing taken out. But it's an absolute challenge. It really is, because people are very protective of their data. And I guess a good thing with this is that they still have it. Because what we don't do is copy it all into the cloud, which is, to be honest, what every other thing in this space does. They always go cloud-hosted data. But we just say cloud-connected data, which actually solves a lot of legal problems too, because some of the Middle Eastern countries, it's against the law to take data out of the country. So you have to store it locally in order to be able to serve everyone. Did I answer your question?
Well, I would disagree with you slightly about the idea that published production figures means the problem is less, because dumb production data doesn't help anybody in understanding the difference in efficiency that an asset might deliver in one person's hands versus another person's hands. You pointed to the value gap right at the beginning.
Yeah.
So if someone else can see how to make your asset run 30% better than you can, they're in a position to add 30% of value to that asset.
Certainly are.
So that's where the conundrum lies, right? It's how you manage that commercial sensitivity while at the same time mobilizing people to look at your data and tell you how to do it.
Yeah. I mean, that's still a problem, however you do it.
It is, but if you want people to connect,
yeah,
there's got to be a way, potentially, to address that problem.
It depends if it's a technical problem or a people problem.
What's the nature of the problem? Is
Yeah.
it a culture problem? Or is
I
it
think it's a culture problem,
Yeah.
and so it's not one I can solve.
I think culture is really important.
I completely agree.
But so my first point about IoT was more about this point. If everybody understands the benefits of IoT, why is it not?
Why is it not everywhere?
Exactly.
Yeah.
So, I mean, that's interesting. If you discuss with external companies who work in this space for other industries, they're just gobsmacked that we're not doing stuff as an industry to the extent that we could. We have data, we have connectivity. So I think we are developing and fitting our way. We need to serve up data. It's well proven in other industries as well. You open up data, you drive an ecosystem, you drive usage of that data, you get greater insight. And actually, most of the time, we're not competing around that data. So if if your field is up for competition or something else, so I can understand it. But basically, if someone came along to you and said, I can help you operate your field 30% better, I would really be looking for that. That'd be good. I'm not down saying the point is that it's actually a challenging sort of psychological relationship we have with data in the industry, but we are beginning to see people who are opening up data, not like Stat or Aitken have just done with their, I forgot the name of the field, but they've released a lot of the data, but they're doing it when they're operating at the beginning. So then if anyone sees anything in the data that they've missed, no one else can drill, no one else can develop in that field, so that would be good. But that is a mindset change, and it is a challenging one. Yeah, and people, I think getting back to the original question, a lot of people are putting stuff into the cloud, into Azure, but you still got to do stuff. You still got to, your Python playbooks and
There is one more analogy here, and it's the first thing that happens when you go into an app. So people are associated with data, they have access to the data, and they can make an app have access to the data too. Just like on your phone, you've got access to your phone and all the instruments on your phone. When you install an app, there's that screen that no one looks at that says, this needs access to your microphone, it needs access to your camera, and it might take pictures of you at night. And effectively, the App Store does the same thing. So you go to an app and it says, for example, one of them is, this needs access to a historical data source. Which ones of your historical data sources are you happy for this to see? So you go tick, tick, not production data. It'll also say things like, this requires offline access to data, which means the app would need to access your data when you're not in the tool. And that's for things that can do alerts and tell you when something happens, even though you're not in the app. So there is that place, but to be honest, that's a technical thing, and it doesn't change the people thing, because the people thing's a bigger issue. Yeah, but it's a perfect question. You're absolutely correct, and it's one of the biggest challenges. But it's what I spent a lot of time doing.
Any other questions?
Just a point in a cultural thing. If all that data is available, would that need to be showing the public the true value of the stuff that's in the ground and not on the smash?
And not
From a political point of view.
All right. Perhaps.
I think it's another cultural question, or another people question, if you want.
Yep.
Well, one of the interesting things about the App Store, I think, is linked to how we as an industry attract younger people and tech-savvy people into the industry and reward them for the skills that they bring. So I'm kind of intrigued about how this interfaces with the social network aspects of how the workplace will evolve and how people will be able to create value as young engineers or young production analysis people or whatever, who might say, well, I can see an opportunity here to use that app and discover some value in the system and deliver that back into the company and see that then reflect in their performance and reward.
Yep.
So in the same way that I like the idea of the App Store as a way to mobilize the external resources and potential to work on the company's problems, I think it's equally interesting to think about how we can mobilize the employees, because they have very different interests. And you'll find people in your organization who love nothing better than to mine this stuff and make it work. I'm not one of them, right? So I'm not a hobbyist who's going to go and attach temperature sensors to its heating, unfortunately. Hobbyist equals spod in my world, but I think this could be something which is very powerful in trying to change the shape of the work dynamic in our industry for the younger engineers.
You're right, and it takes two things. So there are 3 operators that are connected to this right now. I can't tell you their names for the same reason as the concern. But in some cases, they were connected and people weren't aware of the stuff that you could do. And in most cases, they're aware of the stuff they can do and they can't get connected because they need to get through the business. But in that case, which was just recently, I went into an operator and showed them all the tools they could use and went, great, how do we get started? And they said, you've already got it. They went, you're keen. And it was a young guy in that meeting who went, I'm going to champion this and prove to them what I can do with this. And I thought, yes. Because it's exactly what we need. Those people are going to start digging through all that data that they never really saw and find things and go, that was because it's not the tools, it's the people that use the tools and get stuff done.
Yeah, no, I think, so my own experience in my previous role, we would have young engineers doing amazing things in Excel, Spotfire, you know, creating tools to help them do the job. So there was always a challenge around, well, how do you do that and how do you move that into sort of an operational space and challenge. So but like having standard sets of tools and an expectation that it's okay and you know, a means to take that skill set and analyze, take it back and say, well, okay, this is giving you some new insight. How can we change the way we operate to reflect these learnings? It'd be a really good and interesting way of challenging people. And we have to upskill, you know, challenge in the industry as well. How can we use data science more effectively? And one way you can get data scientists, but actually we've got some really smart people in our industry already who are really keen to do this sort of stuff. So it's great. It gives an opportunity for doing that. Any other questions for Steve? So I think we have time for one more question.
Yeah, you mentioned, Steve, that you have one project going with the OGTC. The output of that, will that be published as a case study with reference materials, etc.?
Yeah, so like every project we do, once they complete, there will be a report on what the project was, what the challenges was, what the project did, what were the results, the challenges, the outcomes, etc. So that will be. So we're sort of in the last month or so of that project, and we were actually discussing how best to do that. But that will be like every project that happens at OGTC. There will be an industry report.
We do as an industry tend to look at the negative side, not the positive. You know, it's one of those. It's really hard to get people to do this, but there are people who have, and it's good to highlight that as well, because maybe we'll bring other people along as we do. And it's one of the great things that the OGTC do by making that requirement before you start a project that you're going to publish. Because so many of the things we've done in the past, we can't tell anyone about.